Okay, so we're doing our second one. This is Math 105. This is video number 2. We're still doing the chapter 1.7 in the book. And well, the topic now is absolute value inequalities, absolute value equations, and absolute value inequalities. Okay, so again, we've got our tablet. We've got this thing that looks pretty much like a piece of paper. And I'm gonna try to bring it down a little bit if I can. Can we drag it down here? 1 second. Is this gonna drag it down, or is this gonna drag it down? All right, we'll just start with the way it is. So meanwhile, I bring the pointer up here. I'm gonna choose pencil. That hopefully will be a little thicker. And I'm going to start writing. Here's our topic. Absolute value equations and inequalities. So I need to give you 3 basic problems and absolute value inequalities. So I need to give you, like I just said, I need to give you the 3 basic equations to show you how this all works. So here comes number 1, an absolute value equation. It's got these goalpost bars that I'm trying to write over here. So there's that little bar there, followed by 3 minus 2t, then the other bar, 2 goalposts, plus 4 equals 10. Now, what do I want to do with this? Well, you have an absolute value. It's going to work pretty much like equations to a certain extent. But what I need to do is get the absolute value completely by itself. So I can't have that plus 4 there. I got to get rid of the plus 4. So I do minus 4 on left, minus 4 on right. This is gone. And now I've got the absolute value bars completely by themselves on the left-hand side, preferably, of course, equals 6. And now I'm ready to show you how an absolute value equation works. This is how you treat an absolute value equation once you got the bars by themselves on the left. You branch into 2 branches. On the left-hand side, write 3 minus 2t equals 6. Right? We're dealing with t, not with x. Doesn't matter. And on the right-hand side, you write 3 minus 2t equals negative x. And there's going to be 2 solutions. You're going to come out with 2 solutions for an absolute value equation. We go down the left-hand side and solve. We go down the right-hand side and solve. And we've got our 2 equations. So we have to do minus 3 on left, minus 3 on right. This is gone. We get minus 2t equals 3. Divide by negative 2 on left. Divide by negative 2 on right. And we get 2 is equal to 3 over negative 2, which is fine, or negative 3 halves. I usually don't put the minus on the bottom, really should be in the middle. But there's nothing special over here. And what is this sign over here? Be careful. This is supposed to be a t. And that is one of our answers for this problem. But there's 2 answers. We have to go down this side. We have to do minus 3 on left, minus 3 on right. We get minus 2t equals minus 9. Minus 6 and minus 3 is minus 9. Divide by negative 2 on the left and divide by negative 2 on the right, and we have t is equal to minus over to minus is a plus. We've talked about that during the semester. So it's 9 halves, positive 9 halves, and there's our second solution. So that's an absolute value equation. Here's an example of an absolute value inequality. There's 2 of them. There's going to be one with a less than and one with a greater than. So here comes the one with the less than. Here's my example. You have the bars, then you got 6 plus m. 6 plus m is less than 5. And we don't have to get rid of a plus 4 or anything like that. We don't have to do what we did over here with the plus 4. I want to give a pretty simple situation to show exactly how this works. So if you ever see on your test paper or whatever, or on your homework, absolute value with less than, here's what you do. You put a minus, or that you'd put a copy of that 5, but minus 5 on the left-hand side, then a less than sign, then a 6 plus m, then another less than sign, and then a positive copy of 5. That's what you do every time you have absolute value less than, or the same thing with less than or equal. If there was an equal sign, it would be the exact same thing. And now we solve. We know how to solve. We know how to solve inequalities. We just learned it in video 1. It means that we treat it just like an equation. Just because there's 3 pieces to it, that's okay. We treat it just like an equation. And the only time that we switch the signs is if we divide or multiply by a negative number. But if we never divide or multiply by a negative number, and all the signs stay in the same direction. So what's my goal? I need to get m plane. So I do minus 6 to get rid of that 6. Whatever I do to the left, I do to the right flank, and I do to the left flank. This will be gone. It'll get me m. That's what my goal. Nothing happened. I did not multiply or add by a negative number. I only minus 6. That's not multiplying or adding or multiplying or dividing by a negative number. I just added a negative 6. That's okay. Leave the signs alone. Leave them alone. Negative 5 and negative 6 is negative 11. 5 and negative 6 is negative 1. And this is the solution to the problem. The problem is over. And this brings us to problem number 3, which is absolute value signs. Here, let me give you the example right away. It is absolute value 3x plus 1, and then the bars again. That's a 1. And here's the bars. One bar is bigger than the other, but just bear with me. Greater or equal to 2. What do you do if you have absolute value greater than or greater than equal to the same thing? Greater than or greater than equal, you'd use the same exact system to solve it. What do you do in this situation? Okay, here's what you do. You write as follows. You put on the left-hand side, you write 3x. Hold on, bear with me. 3x plus 1 greater or equal to 2. Then you write an or. 3x plus 1 is less than or equal to not 2, negative 2. And there's going to be 2 solutions, one going down the left sideline, one going down the right sideline. So what do you do in a case like this? You write 3x plus 1 is greater or equal to 2, almost basically exactly like it says, but no longer with the bars. You don't have the bars anymore. And then on the other side, you write 3x plus 1 is less than or equal to negative 2, and we got to solve both, and then we're done. This problem will be over. So minus 1 on both sides. That's gone. 3x is greater or equal to 1. Divide by 3 on both sides. And x is greater or equal to 1/3. And I'm running out of room, so pardon me. Greater or equal to 1/3. Go to the other side. Minus 1 on both sides. And we have, hold on. Here we go. We have 3x is greater or equal to negative 3. Divide by 3 on both sides, and we have x is greater or equal to 1. There's our other solution. Put an or in between, and there's our answer. What's the fancy way? We've talked about this before in class. What's the fancy way to write this? I believe we talked about this earlier in the semester, but here it is. The fancy way to write this would be that the x is greater or equal to 1/3, and instead of the or, we'd have a union sign, right? Both, it's one or the other are both good. Okay, so now let me show you, in other words, as follows. This is the way that you might see it on an answer sheet with that or sign. You might see it on an answer sheet as follows, that x is greater or equal to 1/3 or x is less than or equal to 1. So that means that from negative infinity, x can be from negative infinity until 1. You put a bracket there because 1 is included. Or it could be from, x could be from 1/3. It could be from 1/3, including 1/3, from 1/3, so therefore there's a bracket, and all the way to infinity, because everything greater than 1/3 is fair game. You always put a parentheses next to the infinity or negative infinity. So since it could be equal to 1/3 or greater than 1/3, so it's 1/3, that means it's 1/3 or up all the way to infinity. And since it could be less than or equal to 1, that means all the way from negative infinity up to 1 and including 1 as well. That is the story with absolute value equations and absolute value inequations. Bear with me for a second. I need to come up here. I need to get the eraser this time because I want to show you 3 exercise problems, and then I'm getting off this video so you can work yourselves. I got to go here and click on this to take this eraser. 1 second. 1 second. Does this work yet? Or maybe let's try the other one. 1 minute, bear with me. All right, I'm going to have to practice that eraser. Just bear with me. I have some room here. Let me show you the practice questions that I need to leave you off with. So back to my pencil. Let me get back to my pencil. Here's practice. Here's for my first practice question, as follows. Practice question number 1 is, what if I hand to you the following problem? 2 minus 4t plus 3 equals 13. The second practice problem, 2 minus 4t, those are absolute values. Those are supposed to be the absolute value bars. Okay, number 2 practice exercise question is as follows, is the absolute value 5 minus x plus 2 less than or equal to 14. This will correspond to problem number 2, less than. This corresponds to problem number 1, which is an absolute value equation. And problem number 3 will correspond to problem number 3 that we just did. And the one I want to give you for that is absolute value 2y minus 4. There's the absolute value bar, greater or equal to 8. And that's it. Those are the 3 practice questions. Try them out and go on to the next video. This was video 2. The next one will be hopefully video 3, and I'm going to be getting off. So write those 3 questions down, and those are the practice questions for exactly what we just learned here. So bear with me, please. I got to get my cursor back. Yeah, here we got our cursor back, and I stopped recording very soon. Here we go.